Hello students and welcome to the lesson on similar solids and volume. So what we want to do today is for you to use a scale factor in solving calculation of volumes of similar solids. So remember, when we're using volume, we are using units that are cubed. So as opposed to distance, when we think about 100 centimeters equaling a meter, it's 100 times 100 times 100 centimeters to equal cubic centimeters to equal a cubic meter. So it's 1,000,000 cubic centimeters in a cubic meter. If I think about that for a cubic kilometer, what do we say? We say it's 1,000 meters per kilometer, but then we have to multiply it by 1,000 times 1,000 again. So it's 1,000 million billion, a billion cubic meters to a cubic kilometer. When we want to consider similar solids, we can think of them as having a scale factor. So we have two cubes here, and you can see that quickly we have a scale factor of 4. So if I think about the volume of the original, we've got 3 times 3 times 3, or 3 cubed. That should be 27 cubic centimeters there. Now if we have a look at the next one, it's 12 times 12 times 12, and you can use your calculator for that, of course. So that's 1,278 cubic centimeters. Now we did note that there was a scale factor of 4 between them, so the volume changes quite dramatically once you start moving up with scale factors for volume. Now if I want to cube, if I want to note something, the cube of the scale factor should be the volume of the image divided by the volume of the original. So we're saying that 4 cubed, which is 64, should equal 12 cubed divided by 3 cubed, and that does indeed equal 4 cubed. So we can note this relationship here, that the volume of the image equals the scale factor cubed multiplied by the volume of the original. If we have a look at an example of determining the scale factor first of all, so we're going to consider the first formula we'll think about. So the scale factor cubed equals the volume of the image over the volume of the original. So if I'm looking here, we've got the volume of the image, which is 3,430. We've got the volume of the original. If I divide those two, so volume of the image divided by the volume of the original, we get 343. Now to find the scale factor, we just need to find the cube root of 343. In this case, it is 7. So we can say that this image has been enlarged by a scale factor of 7. Now we could also work forwards, so calculating volume using a scale factor. So we've got 2 cylinders here. We want to calculate the volume of the following shape in cubic centimeters when the scale factor is 3. So all we need to do is substitute in the known volume. That should be V, sorry. I did check that, but oh well, that slipped through. So, and then we're going to multiply it by the scale factor cubed. So 3 cubed is 3 times 3 is 9, times 3 is 27. So 27 times 45 cubic centimeters should equal 1,215 cubic centimeters. Now an embedded object is just a shape within a shape. So if we have a look here, imagine this is something like a famous chocolate object that comes in triangles, which is extremely close to our stomachs or hearts or something, and quite yummy. So calculate the volume of the embedded shape. So that's this little triangular prism here. When the total volume of the shape is 6,000 cubic centimeters. So we just work out the scale factor of 9. So the volume of the image equals the scale factor cubed times the volume of the original. So we just substitute into our formula. We've got 60,000 cubic centimeters divided by, in this case it should be our scale factor of 9. So 9 times 9 times 9. And that should give us a volume of this little area of 8.23 centimeters cubed. So the volume of the cutoff section is 8.23 cubic centimeters. Finally, are you able to obtain a scale factor and use it to solve for scaling problems involving the calculation of volumes of similar solids? And here's my recommended homework so you can exhibit mastery of this concept.